Hey everybody, in this video we're gonna create a Django project and deploy it to AWS the right way following best practices. So you can see here that I have a Django project running and it's actually on the internet under a custom domain that I bought. And if we go to the admin panel, right, that domain /admin, you can see that I can log in as a user and then change user data, which shows that I actually have a connection to a live database in AWS too. So if we actually hop into the AWS console, you can see all that. I got a server here that's running Django on EC2. It's actually a Django image that we're pulling from ECR in AWS. We have a live database connection to an RDS instance in AWS. And we also have a domain up and running here under a domain that I bought, and you can see that it's getting pointed to that Django EC2 instance. And HTTPS is in place, everything's scalable, securely set up with environment variables. We're not sparing any details here, we're doing it the right way. And it's actually really simple to do. All we need to do is change a couple settings in our settings.py file with environment variables. We then Dockerize that entire Django project with a simple Docker file, and then we declare all of those resources in AWS that we want with a Terraform file, and then run apply, and we're done. So whether you're a new programmer or an advanced programmer, you're going to be able to follow every step of the way, and hopefully it will show you how to do things the right way the first time. So with that in mind, let's get started and follow the 6-step process in this blog where we create a Django project, Dockerize it, put it on AWS, stand up a web server, then a database, then the domain, and we're done. So let's go into it. To set up a Django project and properly deploy it to AWS, we're going to follow this blog right here. It's in a link in the description, and we're going to follow its 6-step process. So step 1 is we're going to start a Django project. Obviously, we need a Django project to deploy one. And then we're going to Dockerize it. So we're going to run it inside of a Docker image so that we can run it on any server in any cloud environment. After we Dockerize that image, we're going to push it to Amazon's ECR, so AWS ECR, that's their Elastic Container Registry. And then once it's deployed to their registry, which is basically where you host images, we'll set up a server on AWS and set it up in a way that it can pull that Docker image from the registry. So once we have a server up and running and it's running a Django image, we'll set up PostgreSQL on AWS and we'll connect our Django project to that database. And then last but not least, if you have a custom domain, we'll also show you how to add that custom domain, assuming it's in Route53 in AWS. We'll also look at things in future videos like S3 buckets and other configurations, but with that, let's get started. So let's do step 1. Let's set up the Django project. So the first thing you need to do is run Python 3. I'm going to run Python 312-m pip install Django. We need to install Django in order to start a Django project. So now that that's done, what we want to do is we want to run Django. So Python 312-m Django, Django start project, and we're going to call it Django EC2 complete. And make sure that you run this in the folder that you want to set up the project in. So for me, it's recordings for my YouTube recordings. So you can see if I run ls, that Django project is now complete. So I'm going to cd into that Django EC2 complete project and open it in VS Code. So you can see we have manage.py. We have our main Django directory too. So this is totally a Django project. Let's zoom in a bit. And let's set up a virtual environment too. So Python 3.12-m venv for virtual environment, and we'll also name it venv. Great. So we have a virtual environment set up, which is where we'll host all of our dependencies. Rather than installing it on the computer, we'll store everything in this folder. So to activate the virtual environment, you just run source bin activate. It's enabled, and we want to install the right dependencies. So first, let's install and upgrade pip. That'll take a second. and then let's see what dependencies we need to install. So under Start Django project, we obviously need Django, and then we need to install these 3 dependencies. So Django is obviously needed for Django. Gunicorn allows you to run a Django project in production. And then this PSY cog2 binary allows you to connect to Postgres databases, which is of course needed later. So let's install all 3. So pip install, copy and paste those dependencies. And then once that's done, we need to list out the dependencies in a requirements.txt file so that when we build a Docker image, it knows what dependencies to install. So pip freeze to requirements.txt. Requirements. Nope, need an n.txt. Perfect. So we have our requirements.txt file up and running as well. And this is everything we need to run a Django project. So first, let's run manage.py migrate, and then manage.py run server. And for those who don't know, migrate allows you to spin up a database and apply changes to your database. And then with that in place, we can run server. And voila, this Django project is now up and running. So the next step that we want to do is we want to Dockerize this Django project. We want to take this project, which is now running, and then run it inside of a Docker image instead. So let's go to step 2 and get that started. So in order to Dockerize our Django project, we need to create a Docker file, and that's going to list out the steps in order to build whatever project we need Dockerized. So let's create a Docker file right now. Now make sure you have the Docker extension in VS Code if you want to see this icon pop up. Now, the Docker file is actually very simple, so I'll just explain each line. So we're going to use from Python 3.12 because that's the Python version I have and I'm using. If you're using 3.11 or 3.10, definitely specify it in the from line. Then Python buffered allows you to see the output in the terminal when you run the image, which is useful if you need to debug things or if something's breaking, you want to see that output. We're going to set an environment variable as port 8080 so that we can expose that port and run the project on that port later. And we're going to create a working directory called app, and we'll put all of the contents in this folder. So the dot represents everything right here. We're going to take it all and put it in that app directory. And then we're going to run pip install upgrade, pip install all those dependencies we just listed in requirements.txt, and then run that gunicorn command. And because the app is in working directory and we're running this command in the working directory, it's going to pick up all the files and this command will run and expose the image on port 8080. So let's copy and paste this. And I guess we need to delete the comments. I thought that that would work, but I guess it doesn't. So a few more seconds. Great. So we have a Docker file up and running. Now we need to build this project in that Docker file and then run that image. So let's do that right now. So Docker build -t, because we're going to tag this project. We're going to call it Django EC2 complete. We're going to give it the latest tag. And then the dot represents this Docker file right here. And then once that's done, we'll run the image. We'll expose the port on 8000 and connect that to 8080, which is what we just exposed here internally. And then we'll run that image name and tag. So let's copy and paste this command to start. Control C to leave. So this will take about a minute to generate. And then let's copy and paste this run command. Oh yeah. Okay, so sometimes the base image isn't compatible with the dependencies. So let's just troubleshoot this together. Docker Hub Python. And we go to tags, and if we filter for 3.12, Slim Bullseye is our best bet. So Slim Bullseye images are smaller images, which is better for security. It's better for performance. There's a lot of redundant code in images that you don't need. So if we rerun this, it's going to use a smaller operating system with less code, and there's not going to be that conflict anymore. So if you run into an issue like this building your image, try to find an Alpine image or a Slim image. It usually gets rid of those issues. And you can see it's building way faster this time. Great, and no more issues. Now we can run that run command. So if we go back to the blog, run. I'm also going to add a parameter here. So I'm not just going to paste it and click enter. Before the -p, if you enter -d, it's going to run it in daemon mode, which frees up the terminal right after. So you can see that I can still enter and do things. If you didn't add the -d, it'd be like that never-ending command, and you wouldn't be able to run the terminal anymore. And if you look at Docker PS, you can see that this image is now running with this ID, and it's exposed on port 8000 here. So if we go to localhost 8000, you can see that this image is now running on port 8000. So now what we want to do is we want to take this running image that we have on our computer and put it into Amazon's container registry so that our server can pull from it. Now that we have a Docker image with our Django project inside running, we want to put this on Amazon's AWS Elastic Container Registry. That's where we'll be able to host this image so our server can pull it in real time and run it when we stand it up. So there's two things that we need in order to make this happen. The first, of course, is an AWS account. So if you go to aws.amazon.com, sign in or create a new account, you just click here, obviously sign in or sign up. This is my console. The other thing that we'll need is the AWS CLI. And this is going to allow us to spin up a container registry automatically and then connect our image to it. So do those two things, install the CLI, create an AWS account, and then with that, we'll be able to push this Docker image to AWS ECR. So the first thing we need to do is go back to our project and kill this image. So let's run Docker, kill, and then paste the ID after you run Docker PS. So it's done. If we run Docker PS again, it's not there. Great. So if we hop back to the blog, the first thing that we need to do is create an ECR registry. So install the AWS registry and then run the authentication command, which I believe is AWS login, or if you give it a Google, I'm sure it will tell you the right answer. And then we want to create a repository, and we're going to give it the name Django EC2 complete. So if we do that, it's going to give us a repository URI, which we're going to need for later. So definitely keep this copied for later. So copy that, Command C to kill that. And then now what we need to do is we need to log into our ECR registry. So once you've authenticated with the CLI, you're going to be able to pipe the get login password into a Docker login command for AWS. And this will connect your Docker CLI to Amazon's ECR service. So copy and paste this aspect, the Docker login, and then make sure that you're pasting your URI for the ECR link. Login succeeded. So now when I run Docker commands like Docker push, it's going to push to ECR instead of something like Docker Hub. Great. Now what we can do is we can take that image that we built and retag it. Instead of naming it Django EC2 complete latest, we'll give it the link to our registry and then latest. So let's take the first part, Docker tag, and then copy and paste this URL, and then :latest for the latest tag. Great. And then what we can do is go up here and just change this part, Docker push. So Docker push and then our link :latest. And this will probably take a minute because this image is probably pretty large because we mounted our virtual environment and a few other things, which we could clean up in another video, but we'll just give this a second. Great, so we're done. Now we can validate that this is all completed at the AWS console. So if we go back to AWS and we go to ECR, we should be able to see Django EC2 complete on April 4th, which is today's date, and that latest tag is in there. Perfect. So we got this step done. The next step that we want to do is we want to stand up a server on AWS and run it, pull this image into the server so that when we go to its IP address, you can see the Django project running. So let's do that now. Now, before we get started, I want to talk a little bit about Terraform because it's by far the best way to spin up a web server. When I first started spinning up resources on AWS, I would do it manually by going into the console here, going to EC2, clicking the button to create a new server and following the steps. That's not the best way to do it. If you're spinning up multiple projects and multiple servers, it's best to have it described in code, describe what you want AWS to produce, and then run the script and have it set up. It's way better because it's much more easy to manage, and it's actually easier to spin up resources this way. So we'll do it together for the first time maybe. If you're familiar with Terraform, then you don't need a pitch as to why it's better. So what we need to do is create a main.tf file, and in order for this icon to appear, you need to go to the marketplace and get the extension for Terraform, which is this one right here by Anton. Cool. The other thing that we're going to need is we're going to need the Terraform CLI. It takes only a few seconds, but if you go to install Terraform, just like the AWS CLI, you can just brew install it or do whatever steps you need for Windows, etc. And then you're also going to need to realistically run a Terraform authenticate command too. Cool. Now that we have the main.tf file, the extension, the CLI, and we're authenticated, what we'll need to do is go back to the blog and lean on the Terraform code to spin up each resource needed to spin up a server. And we'll explain each one by one. So the first thing is the Terraform provider. So we're going to tell Terraform that we're going to create resources in AWS. So if you copy and paste the provider and we say it's AWS and I'm going to run in US East 1, you can declare whatever zone you want. If you run Terraform init, it's going to pull in all the APIs needed to spin up resources on AWS. So we'll let that run and then we'll explain some of the other resources we need. So the first thing you need whenever you spin up anything in AWS is a VPC. A VPC stands for Virtual Private Cloud, and it's your own network range to define resources and connect resources within. If you're ever going to do anything in IT, you need a network. This just allows you to define the network your resources will live within. So we're going to give it the CIDR block of this range. This is a lot of different IPs. You don't really need to know much about this notation right now. We're going to enable DNS and we're going to give it the name EC2 VPC. Great. The second thing that we need is an internet gateway to allow access from the internet into this VPC. Right now, this VPC is cut off from the entire world. This internet gateway allows access from the web into this VPC. So the VPC that we're going to be referencing is this one up here. So to connect it, you just do AWS VPC, then .default because that's the name we gave it, and then .id because when this gets created, an ID is assigned, which we can pass in. And of course it gets its own name. Then we're going to create a route table. This allows you to define traffic leaving the VPC. So we have an internet gateway for traffic to come into the VPC, but we also need to define what traffic can leave. So within this VPC, with the same ID, we're going to allow traffic out to any IP address. That's what this 000 notation means. And we're going to bring it through that internet gateway that we defined. Cool. Now we need two subnets. Two subnets are needed whenever you spin up a managed resource like a database, because if one subnet goes down, you need another subnet online for reliability reasons. And subnets are just natural divides within your VPC. So subnet within your VPC for resource allocation, you define different availability zones. So within this VPC with the same ID, we'll have this subrange of IP addresses. We'll put it in this availability zone, US East A, and then the other one will be US East B with a different IP network range. And they of course have different names. Great. We're getting close to the server part, I promise. So the few last things we want to do is we need a route table association to associate the subnets with the route table for internet access, which basically means that internet access we gave the VPC, we want that to carry into the subnets we defined. So we'll paste these two here, and you can see the subnet ID and the route table ID, which are both up here. And then the last two things we need is A, the security group to define what internet traffic can reach our server, and then to define that server. So let's copy and paste the AWS security group. So you can see that we're going to allow traffic from port 22 to port 80 for TCP. This actually isn't needed. We could just specify 80 actually. We don't need 22, that's for SSH, so it could just be from 80 to 80. And that allows for HTTP requests, which are needed for web traffic. And then we're allowing any type of protocol on any port leave to any IP address. Great. And then the last thing is we're going to define a secret key for security purposes. So the secret key is needed for Django. When you go into Django settings, you have a secret key. You want to store that securely. And then let's take the database instance here. So there's a lot to go over here, so let me expand my window. We're going to define an AWS instance, which is a server. We're going to give it the AMI, which is the operating system of this ID, which is Amazon Linux, which is perfectly good. The instance type is going to be a T3 micro, which is the free tier of the Amazon web server. The micros are free, so we're going to keep that one. And we're going to associate it with the first subnet in US 1A availability zone. We're going to give it the security group that we defined above, right? The EC2 security group with just HTTP traffic in and anything out. And we're going to give this server a public IP address. And we're going to run this script anytime we update the server. And we'll explain the script in a second. We're also going to give it an IAM role to pull from ECR, where our Docker image lives. So we'll give that 1 second. And then whenever we spin up the server, we want to run the following script. So we want to install Docker. So we got to install yum. And then we got to yum install Docker. And then start the service. We're also going to install the AWS CLI to be able to log into ECR. So then we're going to run that Docker login, AWS login, that command we ran earlier, to log into this registry here. So make sure we copy and paste our registry link. So just go up here from your earlier command and paste that in. And then we want to pull that image. So you actually want to copy and paste that here as well. And then last but not least, you want to run that Docker image in daemon mode, exposing port 80, pass in that secret key for Django, and paste our registry link too. The last thing we want to do is we want to give this server permission to be able to pull from ECR. So we need to define an IAM role for that. So if we go back to the blog, of course, what's next is the IAM role, and then the attachment to attach it to that server. So if we take these three things here, the IAM role, the policy, which allows it to get access to ECR, and the instance profile, which allows you to link it to the server, paste those three things in, and we have everything needed. Now, I want to take a step back and acknowledge the fact that there's a lot of components in AWS, but whether you define it in Terraform or you do this through the console, you still have to spin these things up every single time. Every one of these pieces, whether it's the network, the VPC, the internet gateway, the subnets, the security groups, the server, the IAM roles for ECR, all this stuff, it's all needed. So maybe take some time to rewatch that section a bit and go through it, Google what each one of these things are just to make sure you're familiar with them. But with all these things in place, you're able to stand up a server. So if we want to run these changes, what we have to do is run Terraform. Okay, thank God Loom's running. Okay. I thought it wasn't recording. Oh my God. Terraform apply. So if you run Terraform apply, this is going to apply all of the changes that we just made in this Terraform file. So the first thing it wants us to do is enter a secret key for Django. I'm just going to use a silly value, but of course make it a secure password. And then this defines everything we're going to spin up when we run this script in AWS. So I know that this is going to work, so I'm just going to enter yes. But usually when you make changes, it will outline what you're adding, subtracting, and changing. So you would be able to determine if that's actually what you want. So this is going to take some time to spin up all of these resources. It should probably take 3 or 4 minutes, but we should be able to go into AWS and start seeing these things get created. So if we go into VPC, that should be one of the first things we see get spun up. So if we go to our VPCs, you can see this Django EC2 VPC just get spun up, which is pretty awesome. We should be able to see, oh wow, everything got created way quicker than I thought it would. Okay, well that's good. So we can go and look at a few other things, like maybe let's look at our subnets. Our subnets 1 and 2 are both up, that's great. Let's go to the server now, EC2. So you should be able to see a server up and running. It's probably initializing right now. Yep. But when we hop into here, we're going to have a public IP address. And if everything ran properly, right, if we go back to our policy, we're running a Docker image on that server and we're exposing it on port 80. And then we defined in our security group that all traffic is allowed to port 80. So if we go to HTTP, paste that address in, port 80, once this is initialized, we should be able to see that it's running. Now we didn't allow this host, but we're getting the error from Django, so we know that this Django image is running. So this is exactly what we want to see. We have a Django image running on this IP, on this server, exposed on port 80. We can add this IP later, but if we're adding our own custom domain name, we'll just add that instead of the IP. But this is exactly what we want to see. In the next section, let's connect a database to this. Let's connect a database to this Django image so that we can store users and we can store our data in a Postgres database. Now that we have our Django image running inside of a web server on AWS, we want to connect that Django image and that web server to a Postgres database so that we can store users and passwords and relevant data and all that. So we can do that in step 5 here. So the first thing we want to do is create a Terraform file that's dedicated to spinning up a database. So we'll call it database.tf. Then what we want to do once that database is spun up is to configure our Django settings to connect to that database we just created. And then back in our web server, when we run that script to run the Docker image, we want to pass in relevant environment variables to connect to that Postgres database. So its IP address, its port, the username and password to authenticate into that database securely. And once we make those changes, the connection is complete. So let's create that database.tf file and define the necessary resources for us to create an AWS. So if we go back to the root of this project, create a new file, call it database.tf. This is where we can start defining the needed resources. So we need a subnet group that links our database instance to the two subnets and availability zones we defined in main.tf. And if you're asking why we define two subnets, it's because AWS requires it. You cannot create a database with it being just linked to one subnet. So let's create that subnet group to link our soon-to-be database to these two subnets. And then we need to create a security group to define what traffic is allowed to and from our database. So if you come down here, AWS security group, within this VPC, the default one, we give it a name, allow Postgres traffic, and we're going to do exactly that. Ingress, so into the database, we're allowing Postgres traffic on port 5432 over TCP from any IP address. And we're allowing any type of protocol, hence -1, on any port to any IP over the web. Now you're probably wondering, why would we do this? That's pretty insecure. You're allowing any IP address to connect to your database. There's a way to lock it down in a future configuration, which we'll show you. So we're going to be passing in the database password as a secure value, as an environment variable. So define the database password as a variable with this module. And then last but not least, we can define this database instance. So if we go to our AWS database instance, 20 gigs of storage, which I think is the minimum, GP2, Postgres is the engine on version 16.1 on a T3 micro hardware, which is free. This is the name we'll give it. So my Django RDS. The database name, we'll call it DjangoDB, Atom, and the password is what we can use to authenticate into that database. And then the subnet group in those two availability zones, that's the association we need. Now, we also need to define the security group, so we're passing that in as a parameter here. So security group RDSSG is the name we gave it and its ID. And then final snapshot to spin up, and publicly accessible. So this is that security part I mentioned. There are times where we're going to want to connect our laptop to the database to create new tables, to create new changes that were made in Django. So if it's publicly accessible, we can do that from our computer. When you want to lock it down in production, you can change this publicly accessible to false, and that means only resources within your VPC can access the database, which is of course more secure, so random people can't access it and try logging in. But for the purposes of creating the tables, we'll need it publicly accessible for now. And this is how you lock it down, change it to false. And we give it a name. So we can run Terraform apply soon. Let's just go back and make sure that we make the final needed changes. So the last thing that we want to do, actually no, we should run this change now. So Terraform apply. So if we run Terraform apply, you're actually going to be prompted to enter the secret key again and the database password again. So in order to prevent that from happening again and again, you can actually just define them by export TFR underscore the variable names and just pass in a value. So I just did that here. And if we run Terraform apply auto approve, it's just going to run actually just Terraform apply. You'll see that we don't need to put in those two values again and again and again. And then you see it always prompts you with the changes and to enter yes. If you just pass in auto approve, it will bypass that too. So in the future, with these variables in place, if you run Terraform apply auto approve, it'll just run every single time. And this is going to spin up the changes, i.e. the new database we just created. So while that's getting spun up, what we're going to want to do is we're going to want to change our Django settings to basically store a secret key securely, allow all hosts to get rid of that error we mentioned, and connect the database, the Postgres database that we're creating as we speak. So let's go into our settings file in Django EC2 complete settings.py and start changing these settings. So the first thing we're going to want to do is import the operating system module from Python so we can pull environment variables and define the secret key as an environment variable. We'll also want to allow all hosts by defining it as star in quotation marks. And then we can ignore this trusted origins part for now because it'll cause issues unless we have a domain linked, which we'll do later. So let's just change this database from SQLite to the Postgres database we're creating right now. So you can see that we're defining the database name, the username, the password, the IP, and the port of the database we're creating, and we know most of these values. So let's define our environment variables right now. If we go into venv, bin, activate, this is where we can define these environment variables. So if you scroll down, this is how you would do it. Export variable name equals value. So secret key I'll keep as this dumb value. Database name is DjangoDB for me. The username is Adam. It might be different for you. The password I'll set as pass1234, and the IP we'll get soon. So let's just give it a second to spin that up. And the database port by default is 5432 and will realistically be the same for you, but we can double check in the console in a few minutes. Now, while that's running, we're able to basically run deactivate and reactivate to apply those new variables. And then we should be able to run migrations on the database we just created. Now, the last thing I actually want to mention is while we're letting this database get spun up, we have to keep in mind that the Docker image is going to be different and it's going to be connecting to that Postgres database, and we need to pass in these environment variables when we run the image. So if we go back to our main.tf file right now, you can see that we're just running this image and passing in a secret key to show you how environment variables work. But we clearly need all of the other ones too, right? We need all these other values. So let's go back into main.tf and copy and paste these other values too. So instead of just the secret key, we're going to need the database name, which is still DjangoDB, mine is still Adam. The user password is pass1234, but we should be able to define that as a DB password. And then the IP we're actually pulling dynamically from the AWS database default address, right? Because if we go back here, we're calling the database instance default, and it creates an address once it's made. So we can pull that in dynamically, which is actually really clever. And then the port is still 5432. And you should be able to actually pull all these things dynamically too, from the database instance, like the username, the password, the database name, but that could be homework for you to try later. Cool. Now the last thing we want to do is just get this database IP properly. So let's wait for this to complete. So if we go into RDS, it should be ready by now. Database instances. So you can see my Django RDS got created. And you can see the endpoint has been made. So now we have all of the environment variables, the secret key, the info to log into the database, the IP and port of the database. So if we run deactivate and then source venv bin activate, this virtual environment got reactivated with these environment variables. So now if we run manage.py migrate, it should be running migrations on the database in the cloud on AWS. And it seems to be working, which is perfect. Now let's create a super user on our database on AWS. So if we run manage.py, create super user, call it Alamore, give it a fake email, stupid password, and the user was created. Great. Now if we run this server, we should be able to actually, if we run the server locally, we should be able to connect to that database that's living in AWS. So if I go to 127.01 and I go to the admin panel, I should be able to log in as that user. Perfect, it worked. So our database is running in AWS and we're able to connect to it locally. And that's because we defined it as publicly accessible, which we can set to false later. Cool. So the last thing that we want to do is we have the database up and running. We have the environment variables being passed in. We have the new settings that connect to Postgres and Python. Now what we want to do is we want to rebuild this image, redeploy it to ECR, and then update our server here to pick up this new image, pass in these relevant environment variables, and we're connecting to Postgres. So let's do that now. So let's go back to the Docker build command. So we just have to rerun this build command. And then we don't need to run Docker run again anymore, but we need to run Docker tag. We need to rerun this tag command and rerun this push command. So this might take a second to complete. Awesome. So then actually if you click up on the keyboard, it's going to show you all your past commands. So it will help us find that old Docker tag command, which is right here. And then let's go up again to find the old Docker push command. Perfect. So it's going to rerun this Docker push command. Now a little interesting note is you can see that our image is now 572 megabytes. That's because we're mounting all of this code, this entire folder, into our Docker image. And now we have a ton of auto-generated Terraform code. We have a whole virtual environment. We honestly have a whole lot of stuff we don't need. So in future videos, I'll show you how to create a Docker ignore file to exclude some of these directories that we don't need. We don't need Terraform inside of our Docker image. We don't use Terraform in production. We just use it to deploy things to production. Same as our virtual environment. We already have Python 3.12 installed in our base image. We don't need all that re-imported. So these would be examples of ways to keep the image size down, which lowers your cloud bill. It makes things faster and more secure. So more on that later. Okay, so our image has been pushed to ECR. We have our Django settings to connect to Postgres, and we made our changes to main.tf so that when we run Docker run, we're passing in the right info, so the new settings get picked up, these variables get applied, and we're connected to our Postgres database. So let's run Terraform apply -- auto approve. And this is going to take probably 3 or 4 minutes, so we'll connect when it's done. In this last section, I'm going to show you how to connect your own custom domain to the server running the Django image that we set up. So you can probably guess where this is going. We're going to set up another Terraform file, and we're going to call it domain.tf. So if we scroll down a little bit to this last step, creating a custom domain, we're going to create a domain.tf file. We're going to create a certificate for HTTPS connections. We're going to create a load balancer that connects any public traffic to any server that we choose. That's the proper scalable way to set it up. And then we're going to create a custom record to link any web traffic from lamore.com or www.lamore.com to that load balancer. And then we're done. So Let's go through each module like the other times we created Terraform files, and I'll explain each one and why they're needed step by step. So create a new Terraform file called domain.tf, or honestly whatever you want to call it. And let's start with the AWS ACM certificate. So this allows you to ask for an SSL certificate to basically enable HTTPS traffic, which is obviously secure and which we obviously need when running an app in production. Now, I'm going to declare this variable called a Route53 zone. So to take a step back, this is for an example where you have purchased your domain on Route53, which is an Amazon Web Service. If you did not do that, we're still going to cover other methods in this video, and most of these resources are still needed. So I'll tell you which ones you don't need if you didn't purchase on Route53. So technically you wouldn't need that one, but let's keep going. Define a Route53 record for cert validation. You wouldn't need this either, but if you used Route53 you would, and it uses a fancy for loop to go through each necessary record for cert validation and make sure those records are in place so that we have SSL. We also want to define two records for lemore.com and www.lemore.com. So you can see lemore.com, www.lemore.com, and then we're going to be linking each one of those to the load balancer that we set up. So this is what we'd be manually setting up in another DNS system like GoDaddy. Cool. And then certificate validation is defined as a resource for when the certificate validation is complete, because it takes a while for it to complete. So we need to use this resource. And then we want a security group for our load balancer. And our security group is only going to allow traffic over 443, which is HTTPS, which is more secure. And it's for all IPs over the internet, so zeros everywhere. And then we're going to create a load balancer and a target group for that load balancer, and then we're going to attach the certificate to it. So create a load balancer, give it a name. It's not internal, it's open to the internet. It's an application load balancer. We define that security group, which allows HTTPS traffic, and it's for both subnets. Which probably isn't needed. We probably only need it for subnet 1 because that's where our server is defined. So let's run a little experiment and just think on the fly for ourselves and trim this down. Unless the load balancer is needed in two subnets, then this might throw an issue. And then a target group essentially allows you to route traffic from the load balancer into the VPC. So of course you make that association, 443 traffic, and you give it a name. And then the target group attachment allows you to take that traffic and turn it into something compatible within your VPC. So for us, the server's exposed on port 80, right? So if we want to link the traffic to that server, then we got to link the instance, say it's on port 80, and give it, I don't know what the target group ARN is for. Oh, we're linking the right target group. So we're saying that it's coming over 443 within this VPC, and then we want to convert it to the server on port 80, which is what it's exposed on. So of course this is needed. And then we want to create a listener, which exposes this to the World Wide Web. Of course, this is all super complicated. AWS makes it complicated. It's not the video that makes it complicated. AWS is super powerful. It allows you to create anything on earth, but with that comes tons and tons and tons of modules that you need to memorize and wrap your head around. There's no way around it. Hopefully this video helps make it easier though. So again, in a nutshell, we create a certificate, we define lemore.com, we make all the mappings to allow for HTTPS, which are all DNS records. We create a DNS record for lemore.com and www.lemore.com, which use the A record to map it to an IP address, which will be our load balancer, certificate validation to make sure that it gets created successfully. This is a security group to allow HTTPS traffic on port 443. A load balancer, which is connected to our subnets, and a target group, which links it to the VPC, and then a group attachment, which allows us to link it to the web server on port 80. So any HTTPS traffic gets converted into HTTP traffic for our server, which it can understand and allow, and then a listener to expose the load balancer on port 443. And -- auto approve. So Terraform apply, auto approve. So this is probably going to take a minute or two to stand up. And it seems like it got created successfully and that we don't need both subnets linked here. And the reason I took out the second subnet here is because the server is only linked to subnet 1. It's the database that's linked to both subnets. So I don't think the load balancer needed to be in the second subnet because that's never connected to the server. And we're linking the domain name lamore.com to the server. Now, of course, also, if we go through lamore.com, there are a few times I use this where you would need to replace it with your own domain name. So obviously the Route 53 zone, the name here. Two availability zones must be specified. Okay, I was wrong. All right. So let's go back and change that. So let's change that, and then we'll meet when this is all done. Okay, so we'll just rerun it. We'll meet up in 4 minutes or whatever when this is all figured out. So all of the resources got completed, so let's see how this looks. So if we go to load balancer, not this one. I think it's the EC2 one. EC2 load balancers. Yeah, so we have this ALB one set up here. You can see that it's internet facing. You can see it's on this IPv4 and then the DNS name. So I'm pretty sure if we go to this, it would actually allow for traffic to the Django image. It doesn't have a cert, but yeah, you can see that it connects to the Django image properly. So what we would need to do is, if you didn't have Route 53, you would point the www.record and the @record, which is just this, with a CNAME, and you would point it right to this, right here. And if you point it to this with a CNAME record, it would be able to link your domain on GoDaddy or Google Domains or whatever to this load balancer here on HTTPS. Now, if we go to lamore.com, you can see that this domain is now running. And if we go to admin and we try to log in, you can see that the origin failed because it's not a trusted origin, but you can see the requests are working. Now, you can see that we skipped this step in the settings in the initial setup. So if we do want this to work, all we have to do is add these trusted origins and of course fix this typo here. So let's just do that now and we'll connect when it's done. So I'll go into settings, I'll go to the top under allowed hosts, I'll add these two origins, fix this typo, and then I'm going to run the docker build command, the docker tag command, the docker push command, and then I'm going to run Terraform destroy and Terraform apply to reset up the server, rerun the script, and pull in the new image. And we should be done after that. So let's just stay on the line until I run Terraform destroy, because I think you could take it from there after. So let's just give this 1 second. Great. And then we'll do Docker tag, and then we'll do Docker push again. That'll take a few seconds. And then in parallel, we'll run Terraform destroy to destroy all of the resources. So enter the database password and the secret key, because we didn't export the environment variables in this terminal. It's going to give us a warning that will shut everything down. So run yes. I want everything destroyed. So that's going to take a little while to run. You can hear my computer sweating right now. And then once the image has been pushed over here, Terraform has destroyed everything over there. We can run Terraform apply from scratch, and it will set up the main file, the database file, and the domain file, link everything together, and we should be fully good to connect from lemore.com and have a production ready app. So everything's being reapplied. I ran Terraform destroy to take all the resources down, and I ran Terraform apply after that to spin all the resources back up. And the reason I did that is because we needed to rerun this script in the web server where we pull the Docker image again, because we updated it with the new allowed origins here. So with all this in place, if we go back to EC2, we should see a new web server running that just got deployed. So let's make sure that's the case. So this is just getting initialized now, so it's very, very new. It might not be ready yet, but let's give it a shot. So if we go to lemore.com/admin, it looks like it's running now. So I'm hopeful. If we go to lemore, we enter that super user admin username and password, auth user does not exist. So it looks like the new database didn't get migrated yet, which makes total sense because we just span it up from scratch. So if we run manage.py migrate, we should re-migrate that database because it's a brand new one. Now, something to be cognizant of here is I just ran Terraform destroy and it destroyed our production database. So you want to be really reluctant to do that in production, because of course you don't want to destroy your production database that has all your user data in it, right? This failed because we deleted the database. So if I actually click refresh, or I go back here, and I do lemore pass 1, 2, 3, 4, it shouldn't work because the user got deleted. So let's create the super user again. So we'll call it lemore adam@mail.com pass Cool. So the user got created again. Let's retry it. Perfect. So under lemore.com, we have a Django image running on this web server. You can see the Django image is living in a container registry, which we're pulling from here, and it's connected to a database that's managed over here, all in AWS, all managed by Terraform, properly and scalably, with a custom domain name on Route53. Now, in future videos, we'll also set up S3 buckets, and we'll set up remaining things. And if you have any other requests, like Stripe or SendGrid or anything, just let me know and I'm happy to make videos for it. But yeah, hopefully this was useful.